Hello my peeps. This Algebra Nation video will cover the right side of page 83 and the left side of page 84.
In this round of videos, we're going to be discussing a system of linear equations. So what is that? A system of linear equations is more than one line. It's two equations that use the same variables, like x and y, and our goal is to find where the two lines intersect, where they meet. For example, if we're given two equations of two lines, we can find where they meet by graphing. So let's first solve by graphing these two equations. And notice, in both these cases, they're already in the form y equals mx plus b. So they both have y equals mx plus b right there, where m is the slope and b is the y-intercept. In this first case, we have y equals x minus 4. And remember, that's a 1x minus 4. So therefore, the slope for this first line is 1, and the y-intercept, b, is negative 4. Remember, to graph a line, you start with the y-intercept and then use your slope. And that's one way to graph a line. So from here, I'll go ahead and plot my y-intercept, negative 4, 1, 2, 3, negative 4, because it's down 1, 2, 3, 4. And then my slope is 1. And remember, that's 1 over 1, so you can see it rises 1 and runs to the right 1. In this case, though, you want to be very, very specific in graphing, because you want to find exactly, if you can, where two lines are going to intersect. So watch, I go up 1 and over 1, but I'm going to do that a bunch of times. Up 1, over 1, 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 up 1, over 1. And then I'll connect all these points. I'll use a straight edge, something like a, I don't know, calculator. Comes in handy, right? Line it up, draw it. It's beautiful. Let's graph the other line. The other line, y equals negative x plus 2. That's a negative 1x plus 2. The slope is negative 1, or rather, negative 1 over 1. And the y-intercept b is 2. From here, we're going to graph the y-intercept, which is 2, 1, 2. And from that point, we're going to go down 1 and over to the right 1. Down 1, over 1, down 1, over 1, down 1, over 1, down 1, over 1, down 1, over 1. You can keep on going if you want to. Okay, connect it. Point, point. And by all means, if you want to, pause the video. Write these two equations down and try and graph it yourself, and make sure you're very specific in graphing your points. The goal is to find where these two lines intersect, and they intersect right here. And that's going to be x is 1, 2, 3, and y is negative 1. So they meet at the point 3, comma, negative 1. Again, the answer would be x is 3, y is negative 1 is where they meet. Then if you want to, you should check the answer and plug it back into both equations. You plug back into both equations, not just one, both. Not one, but both equations. The original equations were y equals x minus 4 and y equals negative x plus 2. Meaning we're going to plug in a 3 for x and a negative 1 for y and see if both sides equal. We're going to plug in a negative 1 for y and a 3 for x. Y is negative 1, x, that'd be negative 3 plus 2. 3 minus 4 is negative 1. Check. Negative 3 plus 2 is negative 1. So both of them are valid, and they both have to work. Again, they both have to work. So make sure that both work. Let's do another, though. Let's find where these lines meet. This first one's...
Before you do another, let's take a brain break, because you don't want to look like this guy on the EOC. Okay, back to work.
Already set up. Y equals mx plus b. This slope is 3 halves. The y-intercept b is negative 4. On my grid, I'll start at the y-intercept -4. I'll go down 1, 2, 3, 4. And the slope is 3/2. So from this point, I'll go up 1, 2, 3, and to the right 2. Up 1, 2, 3, and to the right 2. Up 1, 2, 3, and to the right 2. And I shall connect. That's the first line. The second line is set up so you can find intercepts. Notice it's not in y equals mx plus b form, but rather more in standard form, where you usually would find the intercept. However, don't write this down, just watch for a second. Watch what I do. The x-intercept is when y is 0. The y-intercept is when x is 0. The x-intercept, you replace a 0 for y, and you solve for x. And I get 3x equals 2. But in this case, when I divide by 3, I've got x is 2/3. And we really don't want to graph fractions on the intercepts at all, okay? I don't want to eyeball and go, oh, it's roughly 2/3. No. So instead, let's try and use y equals mx plus b. Let us solve this for y. So that's why I said, don't write this down. Just look and see that if you get a fraction, it's probably a better idea to go ahead and actually solve the equation for y. So on the left-hand side here, now this is what I want you to write. We have 3x minus 2y equal to 2. I'm going to subtract 3x from both sides. Negative 2y equals negative 3x plus 2. Then I'll divide both sides by negative 2. And the negatives 2 simplify. Remember, you divide everything by negative 2. Negative 3 over negative 2 is a positive 3/2 x. Positive 2 over negative 2 is minus 1. And this line has a slope of 3/2 and a y-intercept of negative 1. Go ahead, pause the video, write that down, and try and graph that other line. Again, I'll give you a second. Pause now. Write that all down, and actually graph the other line for me and see where they intersect. The y-intercept is negative 1. From that point, the slope is 3/2. Go up 1, 2, 3, and to the right over 2. Go up 1, 2, 3, and to the right 2. So where do these two lines meet? Where? They don't. They don't meet. These two lines do not meet, they do not intersect, they do not cross. Why not? You can keep on drawing more if you want in one way or the other, but they do not cross. Why do they not cross? If you're looking at what I'm pointing at, both these lines have the same slope. Do you remember what kind of lines have the same slope? Parallel lines. And parallel lines would never meet. Parallel lines would never meet. That's why there would be no place where this intersects. So it doesn't happen at all. It would be no solution. And this brings up a very good point. In fact, little study edge tip for you guys. Two lines can either intersect once, all the time, or not at all. They can intersect once, all the time, or not at all. We saw on the last page that they crisscrossed, and that happened once. We also saw it happen not at all. They were parallel lines, so not at all. How would they intersect infinitely many times? How would they intersect infinitely many times? It has to be the same line. So they gave you the same equation twice. Maybe it was in a different form and you didn't see it yet, but when you graph, you find out that it's one line overlapping another line. So that would be all the time. And these are the only three cases that you will get for two lines overall. These will be the only three cases. It will either happen once, all the time, or not at all. Again, either once, all the time, or not at all. So here we go.
Not today, we don't